My dears, now I've had 10 slightly more difficult factoring questions written for you, again with artificial intelligence. But these are a bit harder than the previous ones. They're thought-provoking, challenging questions. It's going to be great. Let me show them to you one by one. This is the first question. Our second question is another similar one. Third question. This one is also an addition and subtraction question. The fourth question is the same way. All of these are addition and subtraction questions. In the sixth question, we'll learn some slightly different things here. The seventh question is the same as well. 8. Here you can also solve it using the difference of squares, but I'll teach you another method too. Ninth question and the 10th question. Even if these don't appear as standalone factorization questions, they can also show up within other topics. For example, they can be included in polynomials, limits, or derivatives, especially the factorization methods I'll teach you here. If you want to try them before me, go ahead and solve them. If you want to get a printout, there's a link in the description to join the school community, and there's also a direct link to clean and solved PDFs of these documents. I'm starting by explaining the first question. Now, I just remember that we did this question in one of the previous factorization documents. In this question, we need to add and subtract. We'll think about whose square gives us this and this. It comes from the square of x squared plus 1 or minus 1, and we'll put the 1 with the plus here. You'll understand the reason for this in a bit. X squared squared gives x to the fourth, which is right here. The square of 1 gives 1, which is right here. Twice the product of this, and this gives us 2x squared. Do we have 2x squared? We have a part of 2x squared. We have this, but what else should we have had in order to say we obtained 2x squared? We should have had one more x squared. That's why we add and subtract x squared. So we add this yellow one to the other yellows. So all of these together give us this. Then only this remains, minus x squared. Now here, this minus is exactly what we wanted. By making this part positive, we ensured that this part became negative. Because when we made it positive, we used the added positive piece here. The negative piece was left behind. So now we're going to apply the difference of squares. First minus second, first plus second. Usually here, the powers of x are written in descending order. X squared minus x plus 1, x squared plus x plus 1. Now I want something from you. Absolutely. Before you try the second, third, fourth, and even the fifth questions in this column, actually, before you listen to my explanation, try to see for yourself what needs to be added or subtracted. Second question. Now, whose square do these come from? Think about it. What should we add in order to factor this? X squared squared gives x to the fourth power. The square of 2 gives 4. I mentioned that using the plus sign here is an advantage. Let's expand this. X to the fourth plus 2 times the product of these, 4x squared plus 4. This is here and this is here. What's missing? So, which one of these is missing here? 4x squared. We add and subtract 4x squared here. This part is just like this. And minus 4x squared is right here. Now we can do the difference of squares. First minus second. And of course, we'll see this as the perfect square of 2x. And first plus second. Let's write this again in order of decreasing powers of x. X squared minus 2, x plus 2, and x squared plus 2, x plus 2. This is our answer. Third question. Think about it. The perfect square of x squared plus 2y squared. The square of the first is here. The square of the second is here. What does 2 times the product of this and this make? It makes 4x squared y squared. That's why we added 4x squared y squared here and subtracted 4x squared y squared. This part is right here, and this one is here. Minus 4x squared y squared. Let me write that as the perfect square of 2xy. In the next step, I'll factor it. Now, the first is x squared plus 2y squared minus the second, the first plus the second. We could also leave it like this. Usually, in the answer choices, they put the term with xy in the middle and leave it that way. Like this, x squared plus 2xy plus 2y squared. This is our answer. Fourth question, what should we say? X squared plus 8 squared. When we expand it, we get x to the fourth plus 64 plus 16x squared like this. Therefore, there is no 16x squared here. We added 16x squared and subtracted 16x squared. This part is right here. And we wrote minus 16x squared here. In fact, I erased this. Actually, I showed this as the perfect square of 4x. Now we're directly applying the difference of squares. First minus second and first plus second. I'm going to bring the term with x to the middle. X squared minus 4x plus 8 and x squared plus 4x plus 8. This is our answer. What should we do here? First, let's think about where these come from. They come from a squared plus 1 squared. But here it's either positive or negative. This will determine it. Let's try it. If it were positive, it would be a to the fourth plus 2, a squared plus 1. To get minus 6 a squared, there also needs to be a minus 8 a squared here, okay? So for this, we need to say the exact square of a squared plus 1 minus 8 a squared. If we're going to separate this using the difference of squares, we write it as a squared plus 1 minus 2 root 2a and a squared plus 1 plus 2 root 2a. That's how we separate it. This might or might not be in the answer choices. If it's not, that means they've used the other one. Let's take these and put them here. This is what I meant. This was the one with the plus sign. If they've used the one with the minus sign, meaning if they want the student to solve the question from here, what do we get from this? A to the power of 4 minus 2, a squared plus 1. To reach minus 6 a squared, we also need to add minus 4 a squared here. For this, we'll say it's the square of a squared minus 1. Minus 4 a squared? Since 4 is a perfect square, in my opinion, if they ask this, they'll put what we get from here in the answer choices. Because the square root of 8 is 2 root 2. Usually, it's not preferred to leave it like this. Because here, the square root of 4 gives us a direct integer result of 2. I'm writing it like this. A squared minus 1. That is, first minus second. First plus second. Like this. And I'm also arranging it like this. A squared minus 2, a minus 1, and a squared plus 2, a minus 1. This is the answer. Our sixth question. In my opinion, these are important. Listen to me carefully. Here, I'm going to ask you to memorize a little bit. Now, I'm going to explain 3 or 5 rules like these to you, and you'll understand them very well. Now, first of all, when expanding x to the power of 7 minus y to the power of 7, if there's a minus sign in between and the exponents are odd numbers, we can expand it like this. X minus y. If there's a minus here, it starts with a minus here as well. X to the power of... When I multiply this by that to make 7, this must be 6 here. Now, all the rest are plus. There's always a plus sign in between. Plus x to the power of 5, y to the power of 1. Plus x to the power of 4, y to the power of 2. Plus x to the power of 3, y to the power of 3. Plus x to the power of 2, y to the power of 4. Plus x to the power of 1, y to the power of 5, plus y to the power of 6. All right, you won't believe it, but when you expand this is what you get. So when the exponents are odd, it's x to the power of 11 plus y to the power of 11. In that case, it goes like this. It can also be expanded if there's a plus in between. This time, if there's a plus in between, we start with x plus y. When this part is plus, it's plus here. When it's minus here. When this part is minus and it's minus here, everything in between becomes completely positive. When this part is plus and it's plus here, the terms we expand alternate as plus, minus, and so on. So now, when x is multiplied by, what do we get? X to the power of 11. By x to the power of 10. X to the power of 10. This one was positive. Now it becomes negative. X to the power of 9, y to the power of 1. I know y to the power of 1 is usually not written. I wrote it this way so we can see it. X to the power of 8, y to the power of 2. The sum of the exponents is always 10. Minus x to the power of 7, y to the power of 3. Plus, blah, blah, blah. I put 3 dots here. Finally, to get plus y to the power of 11, we will multiply this by the last term. If we multiply y by y to the power of 10, we get y to the power of 11. So we've also determined the last term. So if there's a minus sign in between and the exponents are odd, it expands like this. If there's a plus sign in between and the exponents are odd, it expands like this. If there's a minus sign in between and the exponents are even, this can also be expanded. X minus y, x to the power of 5, x to the power of 4 times y, x to the power of 3 times y squared, x squared times y cubed, x to the first power times y to the fourth, and y to the power of 5. But if there's a plus sign in between and the exponents are even numbers, then you need to do some addition or subtraction, just like we did earlier. Now let's talk about this. X minus 1, x to the power of 4, x to the power of 3, 1 to the power of 1. But since 1 to the power of 1 is just 1, I won't write that. Plus x squared, x to the power of 1 and 1. Finally, check if you get this by multiplying this and this together. So this is our answer. X to the power of 5 plus 1. X plus 1. Now 1 plus 1 minus. X to the power of 4 minus x to the power of 3 plus x squared minus x to the power of 1 plus 1. Finally, let's check if we get this by multiplying this and this together. That's how we solve our 7th question. For our 8th question, we can also solve this using the difference of squares. But now, let me solve it in the way we've learned. X minus 1, x to the power of 7 plus x to the power of 6, x to the power of 5. I put 3 dots and said 1. Multiplying this by this gives minus 1. We've done it correctly. That was the 8th question. 9th question. X plus 1, x to the power of 5 minus x to the power of 4 plus x to the power of 3. Minus x squared plus x to the first power minus 1. Did we do it right? There's a plus 1 here and a minus 1 here. What do we get when we multiply them? When we multiply these, we get minus 1. Is that correct? Of course it's not correct. Why isn't it correct? Because what did we say? When the exponents are even and there's a plus in between, we can't expand it like this. Look here. After explaining this, what did I tell you here? When you have x to the 6th plus y to the 6th, if the exponents are even and there's a plus in between, we can't expand it like that. It can't be expanded like this. Careful. So how do we expand this? In this case, we either see it as the sum of two cubes, like x squared cubed plus 1, and expand it that way. Isn't that right? Or we'll do addition and subtraction. If you ask me, let's write it like this. Let me explain the addition and subtraction method to you as well. First, we see this as a cubed plus 1. Isn't that right? First plus second. The square of the first minus the first times the second plus the square of the second. This is solved this way. How is it solved the other way? Whose square does this come from in the other method? It comes from the square of x cubed plus 1. What actually comes out when you square it? You get x to the 6th plus 2, x cubed plus 1. Is there a 2x cubed here? No, there isn't. Then let's imagine that we add and subtract 2x cubed here, like this. So we set this, and this up like this here. So now we have minus 2x cubed left here. From here, we'll do the difference of squares, but this isn't really suitable for the difference of squares because it will be square root of 2x and square root of x. Honestly, it won't look very nice in the answer choices either. So that's why they usually leave it like this. All right, I'm erasing this as well, and I'm erasing this part too. We saw this as a cube plus b cubed. It says to completely factorize it. If we want, we can factor it like this. X minus 1, x to the power of 11 plus x to the power of 10 plus ... plus 1. Or what else can we do? Or we can expand it like this. We can call this x cubed to the 4th power minus 1. So we think of it like a to the 4th minus 1. A squared minus 1, a squared plus 1, that is a minus 1, a plus 1, and a squared plus 1. The a we mentioned was x cubed. X cubed minus 1, x cubed plus 1. From the square of x cubed, x to the 6th plus 1. For x to the 6th plus 1, we'll say x squared cubed plus 1, and we'll expand this as the sum of two cubes. So x squared plus 1, we just did this, as x to the 4th minus x squared plus 1. This as x plus 1, x squared minus x plus 1, and that as x minus 1, x squared plus x plus 1. So it was asking us to completely factorize it. And this is how our answer will be for this question. Are we good? In my opinion, it was quite nice. The questions here weren't very easy either. Even if you understand some of these now, if you don't review them after a certain period of time, you'll forget them. That's why my suggestion is to get the clean and solved PDFs of these from the description section. Especially try solving the clean PDFs on your own later. You can also join our school community through the link if there are types of questions you'd like to ask me, or if you want me to solve questions from certain types, you can send them. You can do this both through the comments section and within our school community. See you soon. Take care.